Okay. So we have our triangle that has two missing sides, and we're going to use our ratios and solving for our variable to find those side lengths. The first step that I think is super important to do is, oh no. Step 1, set up your ratios. This whole chunk of information right here, our sine of the angle they give us, our cosine of the angle they give us, and our tangent of the angle they give us. Super important to set those up because you need to be able to see where our variables fall in those ratios so you know what you need to solve for. Notice something is different about one of these. Can someone tell me? Yes, John. Has two variables, and can we solve an equation with two variables? No. So that's not very helpful for us. We're going to want to go with cosine of 40 equals 10 over y, and tangent of 40 equals x over 10. So those are the two we're going to work with to find y and to find x. If we come down here, this is us solving for the for y. So we just rewrote it. Cosine of 40 equals 10 over y. To get y by itself, you may have learned you can multiply both sides by y, right? That's how they get the y times cosine of 40 equals 10. Then they divide both sides by cosine of 40 because we're still trying to isolate that y. We just had the y in the denominator. It's hard to work with when it's in the denominator. We got it to the numerator, isolate y. Dividing cosine of 40 on both sides. That's how they get y equals 10 over cosine of 40. Another really interesting way to look at this is if we have cosine of 40 degrees over 1, because if it isn't written, it's over 1, equals 10 over y. If we look at this as a proportion, we can cross multiply, right? So if we just see that it's a proportion immediately, which you can do, you can choose either route, whichever you like best. That will give us y times cosine of 40 equals 10. And then you pick back up, dividing both sides by cosine of 40. Can everyone pull out their calculator and maybe try 10 over cosine of 40 degrees? Because it's super important that we have our calculators in degree mode. I know that calculators automatically are in radian mode, so make sure you switch or else you will be getting some funky answers. I'll pull mine up. If you want to switch yours, if you want to check even, mode at the top up here, and it should be in degrees. If it's not, you scooch down and scooch it over to degrees. Once you do that, then you can calculate 10 over cosine of 40, and I'd like to see some maybe head nods if we do get 13.1. See? Yep, we're good? All right, good. That is what I like to see. Now that we have solved for y, we still have one more variable x. We need to solve for that too, and that's how all of the problems on this page will be. You're solving for y and x. It's a little bit more work, but it's just some algebra and some trig ratios. Coming over here, we have solving for x. We have tangent of 40 equals x divided by 10. To solve for that, how would you isolate that x? What are they doing there? Yeah, Chase? Multiplying. It's being divided by 10, so we do the opposite, multiplying both sides by 10. That's how they get the x by itself equals 10 times tangent of 40. If you want to check on your calculator, you can. Make sure they did a good job. Are we getting 8.4 as x? Yeah? Good. Okay, the last thing I would like to mention to you. This note at the bottom, It's not required of you to do this, but it is super helpful. You can basically check your own quiz or test using Pythagorean theorem. You can tell me if you got the answer right or wrong immediately after doing it. This is a right triangle. Doesn't the Pythagorean theorem work on the right triangles? Yeah, that's the only way it works. So we have a squared plus b squared equals c squared. What does c represent? The hypotenuse. So if you're trying to figure out if you got the answer right, I would plug in our value for one leg, our value for the other leg, square both, add them together, and then you could either square your hypotenuse or take the square root of the left side to make sure that these numbers work out. And they should. It might be a little bit off because of rounding, but you should see that this is a foolproof way to check your own work right there and then. All right, let's try 2 together. All right, we're at the top of that same page in your packet. We're going to solve for x and y. The first thing that is super important to do, I said it was step 1 on the previous slide, is to set up our 3 ratios. Sine of 20 degrees, we have opposite y over hypotenuse 12. We have cosine of 20 degrees equaling adjacent x over 12, the hypotenuse. And lastly, we have tangent of 20 degrees giving us opposite y over the adjacent x. Which one of those is not helpful to us? Tangent. Tangent is not going to be the one we are going to look for to use. You want to solve for y or x first? Pick y. All right, let's go. Sine of 20 degrees equals y over 12. What do we do to both sides? Anyone? Multiply both sides by 12. Easy peasy. 12 times the sine of 20 equals y. Can someone give me an answer when you got it up on your calculator? Well, no, for y, 4.1. Do we see that? Did everyone get that? 12 times the sine of 20 degrees. Make sure you're in degrees. Next, still have to solve for x. So we take our next ratio, that'll help us find x, cosine of 20 degrees equals x over 12. Again, we're multiplying both sides by 12. We have x equals 12 times the cosine of 20 degrees. Using our calculator, we get, anyone? 11.3. You are right. Did everyone get 11.3 when they typed that in? I want to make sure, because I don't think the algebra is tricky. I just want to make sure we're typing in the calculator correctly too. Do we all see how we got x and y? I will do a check for this first one just for the sake of doing it, to make sure we all understand what's happening. 11.3 squared plus 4.1 squared. What do we get when we do that? Is anyone checking their work too? It's a good idea. Just using the Pythagorean theorem to check. What'd you get? So when you just type this in, 144, and yeah, there's going to be some funky decimals, and we know that 144 is just 12 squared, and that checks out. We're good. 12 is our hypotenuse. We will scroll back up and we will do number 2 together. Make sure we got this down. Step 1, write our ratios. We have sine of 15, that's a 15 degrees. Sine of 15, we have opposite 10 over hypotenuse, that's our x over there. Cosine of 15 degrees, cosine adjacent y over the hypotenuse x. Tangent of 15 degrees, we have opposite 10 over adjacent y. Which one's no good for us? Cosine. We have 2 variables. Can't do that. All right. Moving on down, let's solve for x. Sine of 15 equals 10 times x. Now this is where I showed you could either multiply both sides by x, or you could look at them as proportions, whichever one helps you. I'll look at it as a proportion for you guys. I'm going to cross multiply. I have x times sine of 15 equals 10. Makes no difference if you multiply both sides by x. It's the same idea, same math. Dividing both sides by sine of 15 to isolate that x. What am I doing? And now we have x equals 10 over sine of 15. Can someone shout out what they got maybe for 15.4? 10 over the sine of 15. Are you in degrees? Make sure you're in degrees. And make sure maybe, I always put extra parentheses. When I type it in, I'll type in 10 divided by the sine of 15 just to make sure that it's doing it right. I know that not necessary. I just am paranoid. But John said it, x equals 38.6. You are right. And then we have to solve for y. So we use our ratio that we got using tangent. Tangent of 15 degrees is 10 over y. I'll do this one with multiplication. I did the first one with proportions. Multiplying both sides by y. The y's cancel out on that side. And we have y times tangent of 15 equals 10. Dividing both sides by tangent of 15 to get that y isolated. Yeah? 37.3 is correct. So 37.3, did everyone get 37.3? Make sense? You could do the check again. I think it's always smart to do the check to make sure you're understanding it, you're doing it correctly. Now I'll cut you loose and you can go ahead and start on the rest of that page because that is for homework. You also have some book work that is due, and I'll walk around and answer any questions.